Hello, everybody. Welcome back to Edu-Malanga, our maths educational channel where we make Matric maths videos for the South African syllabus. What are we doing today? What are we covering today is inverse functions. The previous video covered the explanation behind inverse functions. I've also covered functions in general, which includes an explanation of inverse functions. And today I'm going to be doing the first example of an inverse function. As I go through it, I'm going to be very, very lenient because I know that sometimes sleep is life, guys. And I'm going to make sure that as I go, I'll explain, to an extent what we've covered before so that you can understand inverse functions through the example. But if you still don't get it, please go back to the previous video, inverse functions, and go back and understand what an inverse function is, and that will help you a lot. And then you can redo the example, and I think then you'll get the benefit that I would hope that you lovelies get. All right, okay, I'm gonna start with this example. So, guys, get your test paper. You write the heading. My handwriting is something to forgive. On a good day, pray for me. Pray for me. Pray for this handwriting. Really? Okay. So okay, guys. Again, I'll just sort of explain as we go along. Okay. Given the straight line, so let's say you were sitting during inside of an exam or a test. This is like an example of a question you would get there. Given the straight line, so we remember what a straight line function is. If you don't remember what a straight line function is, please go back to the functions video. I think I'm generous with explaining, but there comes a point where we have to be honest with each other, and a straight line is something you should know before you get here. But I will explain nonetheless. Given the straight line, y, okay, is equal to mx plus c. Okay, guys, so y is all of the coordinates on the vertical axis. If you could follow my cursor, the vertical axis just means straight from up down, okay? Is equal to m. M is the gradient. M is the gradient or the slope or how much the graph is leaning, okay? So this is a straight line. So a straight line essentially is a line. So the graph can lean this way, can lean that way, it can be straight like this, and it can be straight vertical. And that's what M stands for. It's how it is leaning. And you get M by saying y over x, or y1 minus y2 over x1 minus x2. Just pretty much getting the gradient of the graph. X is the x coordinates of the graph, where all points all points that coordinate or correspond to x. And c is because you would make this a 0 and then you'd get y is equal to c. So therefore, where it intercepts the y-axis. Y-axis, because that would be at x is equal to 0 and x is equal to 0 is along the vertical line. Okay, so given this is your straight line, defined by the function fx, okay, this is just a function name, is equal to the x plus 3. So essentially that is the same as y is equal to x plus 3. When you get this, you will know it is a straight line because it corresponds with this this form of writing a graph. When x doesn't have a 2 here or a 3 here or anything here, but it is instead just x on its own. What you see here is before the x we have 1. So the gradient of this graph is a positive 1. And then the y-intercept is 3. And then we've got x and y. Okay. So the question will read as find the inverse of the straight line. So remember in the previous graph, in the previous video, we explained different methods in which you can denote or write what it means that something is the inverse. And the inverse of this is denoted by putting this negative 1 up here. That's how you know that it is a graph that is inverted. It's because if you see negative 1. This is not the same, and I put this in the previous graph, this is not the same as 1 over fx. Okay, So there you go, not equal. Instead, it is the inverse. Okay. And one of the things that I said towards the end of the last video is that what an inverse is essentially is I just invert the graph. So where I had x and y as coordinates, I now have y and x. Okay. And I will explain that further as we go along. So that's our question. We're in the exam, we're sitting there in the test, chilled vibes for days. So what I'm going to do in order to, given the straight line, finding the inverse, one of the ways I could do it is I could plot the graph itself, right? I could plot f, which is our graph, and okay. So to plot graphs is pretty easy because, okay, f at 0, f at 1. This is a very nice way to do it. Like, just choose points that are very obvious. F at -1. Okay. But remembering that we said fx is equal to, go back to the previous slide, is x plus 3. So then we just say, here at 0, it's 0 plus 3. F at 1 then becomes 1 plus 3. F at -1 becomes -1 plus 3. What this gives is 3. What this gives is 4. And what this gives, -1 plus 3, is 2. Okay. Essentially it's like 3 minus 1, if you don't understand that. Okay, so if we look at this graph here, we've got certain values that correspond to x, which are these ones. X. This is an x value. This is an x value. This is an x value. What I mean by that is it's found on the horizontal part of our graph. This is a y value because this you wrote out like that, but it is the same as y equals to x plus 3, right? So that becomes a y value. 4 again becomes a y value that corresponds to this point. 2 becomes a y value. Okay. Then if I were to write the domain and the range of this graph, for domain, I would just look at the x values. And for range, I would look at the y values. It's that simple. Like, don't complicate it for yourself. Range, y, x, domain, x. Okay. So I look at the x values. There's a 0, there's a 1, there's a -1. So to write it properly, I'm going to start with the smallest number, and then I go to the biggest number. Then I go to the numbers that correspond to that. -1 corresponds to 2. Don't mix it up, okay? 0 corresponded with 3. And 1 corresponded with 4. That becomes our range. That becomes our domain. Now, guys, so the interesting part, I'm going to give you the points. So these are the points I'm going to plot out. Literally 0, 3, 1, 4, -1, 2. But I'm going to plot it out when I have the inverse coordinates just so that we can plot once. But I'll explain clearly as we go so you can see what we're doing. Okay. Therefore, for the inverse, guys, remember. Kumlekaya. Okay, remember what we said. Essentially, the inverse is I'm going to just take an x value and a y value, and I'm going to correspond it. So the inverse, therefore, of fx, which is which we said is y is equal to x plus 3. Right. Okay. So I'm now going to show you guys the inverse function. Or one of the ways in which you can get the inverse. Okay, so we can just swap where y is and put x where y is. So this is the graph we had, essentially. So this is the original. The original is y is equal to x plus 3. The inverse, therefore, becomes x is equal to y plus 3. You saw what I did. I took where x was and I put y. I took where y was and I put an x. Okay, therefore, this is how I denote it. I can easily denote it like this because I know for a fact that a straight line, one-to-one function, the inverse will also be a function. This is something I explained in the previous video. I'm not going to explain it in depth, But essentially what it means is that if I were to draw a vertical line through the graph, I'm still going to get it crossing at one point, therefore calling it a function, because that's how we decide whether something is a function or not. And with something like a parabola, you're not easily going to get another function just because when it turns over, it starts crossing on two sides, okay? As I go through the examples, I've got two examples to go through. You're going to see this more and more. So if you're not fully conversant with thought, just hold it there, think about it. If you're not like fully understanding what I mean by that, just like think about it, put it to the back of your head or write it on your book, whatever. I'm coming back there. And I'll re-explain why we call it a one-to-one, a many-to-one function, and whether the inverse is also a function. Okay. Yeah. Otherwise, like guys, comment below, like whatever, inbox us, and we will explain. Okay. So this is the inverted function. So in order to like write it easily so that I can understand it, in order to make it this, I'm going to put a y. I'm going to make y the subject of the formula, which is what we normally understand functions to look like. So if I put y here, I'm going to have to take 3 over to the other side. Okay, we get it? Y stays on its own, y there. 3 must go to the other side. So I say x remains there, minus 3. Do we get it? I swapped, remember in the beginning, that was the function. I swapped out x and y. And then I take 3 and I move it to the side. So y can become the subject of the formula again. Okay. What happens there is that the new function becomes x minus 3. Okay. Then I plot it again at the same points that I plotted last time. So same function at 0. Inverse at 1. Inverse at negative 1. Okay, what I get is that here it becomes 0 minus 3. Here I get 1 minus 3. Here I get negative 1 minus 3. As I said, 0 minus 3 is negative 3. If you don't understand how this works, essentially you're already at 0 and you're taking away another 3. You can also just do it in your calculator because I know that is allowed in Matric. Okay, negative 1 minus negative 3. 1 minus 3. So 1 minus 3, 1 goes there, and then left with negative 2. Okay, you could also do it in your calculator if you understand. Negative 1 minus 3 becomes a bigger negative, so negative 4. Okay. So what we then get is a new range and a new domain. I'm going to write it down for you. I get a new range and I get a new domain. Okay, so the domain of the inverse becomes the same thing, which is negative 1, 0, 1. The range, therefore, which is the corresponding values, became negative 4, 0 corresponded with negative 3. The 1 corresponded to negative 2. Okay, now I just have to plot the graphs so that we complete this and understand it completely and understand how it corresponds to being inverted across the line y is equal to x. Okay, so here's my graph here on the one side of the page, and I'm going to draw. I've been doing this for a couple of weeks on this graph. It's like the best I could get that doesn't take up too much space. Bear with me, please draw more accurately where you are at home. This is the graph that we have here, okay? And this is the y-axis, this is the x-axis. This is my point 0, 0. Okay, so in order to draw the first graph, I remember that the domain and the range of the first graph was negative 1, 0, 1, corresponding to 2, 3, 4. Okay, so original. Okay, I had a domain, negative 1, 0, 1. Range was 2, 3, and 4. You can double check that on this side. Negative 1, 0, 1, 2, 3, 4. Okay, so for the original graph, I'm going to draw it in different colors. I haven't really done that, but let's do it. Let's try something new. I'm going to draw the original in red. Okay, so here is the 0, 0. So I'm going to draw the first point as negative 1, moving on the x-axis, and 2. So negative 1 corresponds to 2. Okay, so there's the first point. Then the next point is 0, 3. 0 on the x-axis, 1, 2, 3. Remember when I first did this thing, I said the value C is where the graph intercepts the y-axis. So this 3 over here, right, becomes this 3 over here becomes where the graph intercepts. So that's how it's a nice way to check if you've drawn your graph right. So us, yes, it's corresponding at 3, so it's perfect. And then we have 1 corresponding with 4. So okay, so 1 on the x-axis corresponding with 4. So 1, 2, 3, 4. There we are, we plotted there. So then I can now join these 3 like this, and I get fx. Now we need to plot f dash x or f inverted. I change the color again so that we're not getting confused. I'm going to change it to blue. The new range and domain is this one here. So -1 corresponds to -4. -1, when I go 1, 2, 3, 4. So the negatives is, if it's a y, it's on the bottom. If it's an x, it's on this side, which would be on the left of your page. And then if it's positive, it's on the right of your page. So I'm going to show you that again. So 0, -3, again, it's negative, so it's going to be at the bottom. So 0 on the x, but it's now 1, 2, 3. Remember we said the intercept becomes this value. Y is equal to m, which is 1, x minus 3. So minus 3 is the intercept. So that's how you check your graph for correctness. And then you could also just do the y over x to get the gradient, which is the m. Then we get 1, -2. So 1 this side, which is the right of your graph, and then you go down 1, 2. So you get -2. Then I join these, and I draw. Try not to draw too inaccurately, f -1 x. This becomes the inverse. Okay. So essentially, probably get the marks. You've probably done everything you can. Good for you. Okay. But, however, if I had to draw a line here, okay, going through all these points here, it's about accurate. Y is equal to x. And say this graph was y is equal to x. And I made this a mirror line. I put a mirror here. This graph is essentially what I took from here and I put it here. That's how I got the inverse. Again, it is a straight line function. So I can draw a line here, down, and I conduct the vertical line test. If we check carefully, the line crosses the axis, across the graph is crossed at this point over here, and again, nowhere else, this graph. Here as well, it's crossed just there. So what we get is that the function, this function is also a function there. We're going to see with a parabola in my next example video, that it's not always the case, but just remember when we're drawing a straight line that your inverse is indeed a function. So, okay guys, just a recap before I say goodbye to you amazing people. The question was, given the straight line, draw the inverse. So we first drew the first graph, and we drew the original graph, we plotted it out, got the domain and the range, and then we did the same for the inverse, and then we could draw both on the graph, and you can understand how one is mirrored across the line. Guys, please enjoy our videos. Please also comment down below. Love you. Bye.